Our question states, what is the free body diagram of an object on a ramp that experiences friction? So this one's simply testing us on how to make a free body diagram. First, what we do, we make a point that represents our object. Now we need to think of the forces that are acting on said object. If we were to draw a photo of what this looks like, we're going to see a ramp. We're going to see that this is equal to level ground, and that we have an angle of said ramp. And I'm going to represent that with theta. We also have our object, which we're going to say is a box. And then, now that we have that going for us, we know how this is going to work. We know that our normal force is always perpendicular to the surface that the object lies on. So, we know that our normal force has to be going up this way. I'm going to use F of n to represent normal force so that there's no confusion with the actual letter n with other equations. We also know that our gravity is always going straight down towards the Earth. That means that we have now a force of gravity going in that direction. We also know that if the free body diagram represents an object that is traveling down, which I actually forgot to mention in this, it does ask for an object that is traveling down, we know that friction must be in the opposite direction of the travel of the object, which in this case, if the object were traveling down at a constant speed, let's just say it's just traveling down, that means that our friction must be in the opposite direction, which means our friction has to be going this way. Force of friction. Now, a couple things I would like to note is that force of friction is always going to be parallel to the direction of the surface. So if the surface is traveling in this direction, our force of friction is going to be that direction. Our normal force is always perpendicular to this. So that means if that's it there, then it's going to be perpendicular to that there, which means that our force normal and our force of friction are going to be perpendicular to one another, represented by that square. And now this force of gravity always just goes straight down, so it has no correlation to the other two. This would be your completed free body diagram.